as usual, we have a problem that involves the manipulation of fractions. However, we find that this kind of a problem you will find more often than the other type on the examination paper. In number 1, we do not always have fractions to manipulate in this form, but we find that the problems involving fractions are the one that we have more often than not. Before going into the manipulation of the fractions, as usual, let us convert the mixed numbers to improper fractions. There we have labeled the different parts of the mixed number. We have the whole number, we have the numerator, and we have the denominator. In converting the mixed number to an improper fraction, first we multiply the denominator of the fraction by the whole number. That we will do first. So 4 multiplied by 1 is equal to 4. Then we proceed to add the numerator to the result. So 4 plus 3 is equal to 7. So 4 times 1 is 4, plus 3 is equal to 7, and that will be the numerator of the improper fraction. And of course, the denominator is the same as before. Do the same. Denominator, multiply that by the whole number. The result is 6. To that result of 6, we add the numerator, which is 1. 6 plus 1 is equal to 7. And that is the numerator of the improper fraction, and the denominator will be the same as the denominator that we had before. So let us go straight ahead, rewriting the expression that we have using the improper fractions that we obtained on the previous slide. So we have converted 1 3/4 to 7/4, and we have also converted 3 1/2 to 7/2. Squaring a fraction is the same as squaring its numerator and squaring its denominator. So whereas we have 7/4 squared, to achieve the squaring of the fraction, we need to square the 7 and square the 4. In the meantime, what we have done is make use of the fact that dividing by any number for that matter is the same as multiplying by its reciprocal or multiplicative inverse. So we have, of course, squaring the 7 we get 49, squaring the 4 we get 16. Then we make use of the fact that dividing by a fraction or any number for that matter is actually multiplying by its reciprocal. So we have formed the reciprocal of 7/2, which is 2/7, and of course we have squared this fraction here. And we see common factors, so we will reduce the fraction by common factors. So the fraction may be reduced by a common factor of 7, then by a common factor of 2. We have 7 into 7 is 1, and 7 into 49 is 7. Of course, 2 into 2 is 1, and 2 into 16 is 8. So 7 into 7 is 1, 7 into 49 is 7. 2 into 16 is 8, and 2 into 2 is 1. 7 multiplied by 1 is 7, and multiply 8 by 1 we get 8. and that's all there is to it. Multiply the numbers as we have said before. 7 multiplied by 1 is 7, and we do that to the denominators also. Now we'll be working with decimals. Especially in recent years, the problems that require that we find the square root may be solved without the use of the calculator. We know that because there are 4 decimal places in the number, the square root will have 2 decimal places. So if we have a particular number, especially if the number of decimal places is even, say 6 decimal places, if we find the square root of that number, then the square root should have 3 decimal places. So while taking the square root of a number, we take half of the number of decimal places. Now we have 4 decimal places right there. Taking half of 4 is 2. So the answer should have 2 decimal places. Also, because 529 is close to 625, we may say that is not so close. Well, at least for a square, they are very close if we are talking about squares. Because if we square 20, we get 400. If we square 21, we get 441. That one is, as a matter of fact, 41 units away. But because they are squares, we imagine that the greater the number that we square, then the further the numbers will be apart. Therefore, if we have 529 and 625, we think that those should be relatively close to each other, being square numbers, if we are saying that 529 is a square. So they should be very close. Now, since 625 is equal to 25 squared, then 529 could be, I'm not saying that it is, could be 23 squared. Because if the squares are close, we imagine that the numbers should be close, so we are just opting for 23. Now, focusing on the 9, 3 squared may also be a good clue. So if we are thinking about the 9 at the end, squaring 3 we get 9, although squaring a number that ends with a 7 also gives a number that ends with a 9. But we are saying that we are focusing on 23. So if it is actually the square of 23, then squaring 3 to give 9 will also be a good clue. So sometimes we could take an approach where we set aside the calculator and make use of our brain. Your calculator would have revealed that the square root of 0.0529 is in fact 0.23. I hope that no one attempted to add before finding the square root. Well, it is far-fetched that anyone would want to add this number to this one and then find the square root. We don't imagine that anyone will want to do that, but stranger things have happened. Now we will do the square root first, and then when we get the result, we add 0.216 to it. And we said that the square root of 0.0529, we could imagine without using the calculator that it is actually 0.23. But these days, CSEC examiners imagine that students have the calculators at their fingertips, so they expect that students will use them. So we have 0.23 plus 0.216, and that may be done in our minds without the use of a calculator. As a matter of fact, we realize that if we align the decimal places, although we're not doing that physically, but mentally we should be able to handle problems like these. If we align the decimal places, there will be no decimal place that is in line with the 6. It will go back, so we have a 6 there. So on the alignment of the decimal places, we realize that there is nothing that will be aligned with the 6. It will go right back, and we see that 1 plus 3 will be 4, and 2 plus 2 is 4, so 0.446, like that. It is required that the answer be finally written in standard form. There should be one non-zero digit to the left of the decimal point. By so doing, the number will be increased by 1 decimal place, or multiplied by 10. An adjustment will have to be made that will return the number to its initial value. We therefore divide by 10, which is equivalent to multiplying by 10 to the negative 1. So there we have it. Now we have this number 0.446. To write this in standard form requires that the decimal point will be here instead of here. By so doing, it means that we will be multiplying or increasing the number by 1 place of decimal. So we are increasing its value by 1 place of decimal, which is the same thing as multiplying by 10. Now we cannot just leave the number multiplied by 10. We have to bring it to its original value. So if we multiply by 10, to bring it back to its original value, we'll have to divide by 10. Dividing by 10 is the same as multiplying by 10 to the power of negative 1, and hence what we have right here. We may consider that making a small number larger will have to be compensated by making it small again. Therefore, any number that initially had 0 preceding the decimal point will be accompanied by a negative power of 10 in the end. The power of 10 will be determined by the number of decimal places by which it was increased. Therefore, if we have a small number, what we call a small number is a number with no non-zero digit preceding it. Therefore, any number that has 0 point something, we will consider that to be a small number. In the end, that number will have to be accompanied by a negative power of 10, because having 0 here means that we can only, by writing it in standard form, increase its value. Therefore, we will have to decrease its value again. So if we have no non-zero digit preceding the decimal point, we imagine that in the end we will have our number accompanied by a negative power of 10, and the power is determined by the number of decimal places that we increase the initial number by. Now we are given this problem in which the hourly rate of pay is $22.50, and we are talking about a 40 hours work week, and we need to find the weekly wage, and that will be done by, of course, multiplying the number of hours by how much is worked in a particular hour, and that is a simple result. $22.50 multiplied by 40 is equal to 900. As a matter of fact, 22 times 40 is equal to 880, and a half, so we have 0.5, which is a half. A half of 40 is 20, so we have 880 plus 20, and that will give us 900. So that is also something that we could have done mentally. 1.5 times the hourly rate may be taken at face value. We always associate times with multiplication. So for 1 hour of overtime, we multiply the hourly rate by 1.5. So we just need to determine the overtime rate, which is the overtime hourly rate, and it is 1.5 times. So multiply 1.5 times the hourly rate. So we have $22.50 multiplied by 1.5, which is 1.5, and this is the hourly rate, and this is the hourly rate for overtime work. We are told that the number of hours worked in a particular week is 52, and we need to know her wage for that particular week. What does that mean? If she is working 52 hours, that means she should be working a certain number of hours more than the regular working hours, because the regular working hours is 40 hours. Therefore, if she is working 52 hours, she is somewhat over that. Now we need to determine, because we just cannot go straight ahead and do all the calculations together, we have to consider that there is a particular rate, which is a different rate for regular hour as opposed to overtime hours. So we need to separate the regular time from the overtime, and we have 40 hours for regular time, so the overtime will be the difference between the regular hours and the total number of hours. 52 is the number of hours that she worked, and 40 is the number of regular hours. The difference between that will be the overtime hours. So 52 minus 40 is equal to 12. So that will be the number of hours that she worked overtime. The number of hours that we have calculated for the overtime will be multiplied by the overtime rate. And of course, we know that the regular wage for the week is what we have right here, is $900. So those $900 will represent all of the hours that she worked regularly, and then we'll add the overtime, which is 12 multiplied by the overtime rate. We'll add that to it. So there we have $900 plus 12 times the number of hours, that is 12 multiplied by the overtime rate, and that gives $1,305. In order to find the number of hours that she would need to work in order to earn $1,440, we need to subtract the regular weekly wage from that amount in order to determine the amount that she would earn in overtime wages. Then divide that amount by the hourly overtime rate. So we have 1,440. We will take away the regular wage from that, and then divide this value by the overtime rate and see what happens. So that turns out to be 16 hours. So we have 1,440, which is the amount of money that she needs to work. We subtract the regular salary, and with that result we divide by the overtime rate, and that turns out to be 16 hours. What we could have done also, we could have found the difference between this and the 1,440. Then we would divide that by $33.75, and after doing that, the result would turn out to be just 4 hours. Therefore, with the 12, the 4 hours will turn out to be 16 hours. So we could have taken that approach also. There we have a system of simultaneous equations. Examiners have a way to play hide and seek with simultaneous equations. There is usually a simpler way out than what we would capture at first glance. Taking a second look at the system will reveal that the coefficients of y are additive inverses. They have different signs but are the same in value. Adding them will result in 0. We may therefore go ahead and add the two equations. eliminating the y's. So we have a positive 2 here and we have a negative 2 there. If we add them together, the result is 0. We may go straight ahead and add the two equations. I am sure that some students will see it a little bit simple also, not simpler, will see it simple to just multiply this equation by 3 and then find the difference, which may be simpler than what we would expect, but they're simpler still, with the coefficients of y being additive inverses. So we add the two equations and the y's are eliminated. 3x plus x is 4x, and 13 plus a negative 1, which is 13 minus 1, is equal to 12. We have 4x and 12. Dividing the equations by 4, the x will be the only thing left on the left hand side. The 4 will be eliminated, and 12 divided by 4 is equal to 3. So x is equal to 3. Take that result, which is x is equal to 3, and substitute that into equation 1. So in equation 1, where we see x, we replace that with 3. And then of course we have 2y and then 13. So we have 3 times x, which is x is 3. So 3 times 3 plus 2y is equal to 13. And of course 3 times 3 is equal to 9. So we have 2y is equal to 13 minus 9. So 2y is equal to 4. And y is equal to 2, dividing through this equation by 2. So x is equal to 3 and y is equal to 2. As in all cases, when solving a pair of simultaneous equations, we may eliminate either the x's or the y's. We should progress, making use of any loop of simplicity that exists. Whenever we are manipulating positive and negative numbers, it is always easier to add than to subtract. Making use of additive inverses when they exist or are easily created is usually a simpler route. So making use of additive inverses, I always try to do that if it is an easier way out. If we see additive inverses, then we make use of them. If they are easily created, then we create them and then we move straight ahead. But we always try to make use of any what we call loop of simplicity that exists. Although it might not be so in all cases, examiners more often than not make it at least a little more time consuming to eliminate the x's than the y's. This technique is for candidates who are programmed to invariably eliminate the x's. Do not forget that 2 takes longer than 5. It is better to take an extra 5 seconds to examine a pair of simultaneous equations than an extra 2 minutes to solve it. So a system of simultaneous equations, it is better for you to take an extra 5 seconds to examine the system than to take an extra 2 minutes to solve it. Now we are about to factorize completely, and this first expression to be factorized is in the form of a difference of 2 squares, everybody's favorite. It is required to be factorized at sight. Usually we imagine that it attracts only a single mark in the examination, factorizing a difference of 2 squares. Therefore we do not imagine that it should take 3 steps in entirety. So there we have it. X squared is the square of x. X occupies the first position in both pairs of brackets. So we have x there and we have x there. Also, we need to know what we square to give 16. 16 is the square of 4. 4 will occupy the second position. And in the end, we will place a negative sign in one bracket and a positive sign in the other. And the order does not matter. That is, if we put plus here and negative here, or put negative here and plus there, then it will not matter, as long as the two signs are not the same. And that is our answer. Now we have our expression, 4 terms. We will use factorization by grouping. So for this expression, we may factorize in pairs, then factorize the expression as a whole. So we have that, which is, as a matter of fact, being a little bit elaborate, because it is not completely necessary to include this intermediate step, but I'm just including these steps. We'll have another one in order to make the process clearer. So we are actually taking the common factor of x, and then we are dividing each term by the common factor. So the common factor, what is common in 2x squared and 3x? X is common, so we take the x here, and 2x squared we divide by x, and also 3x we divide by x. Also, what is common in 8x and 12? 4 is common. Generally, we take the highest common factor because we are in the habit of factorizing completely, and that can only be achieved if we take the highest common factor. And we say now 4 into 8x there, so 8x divided by 4, and also we take the 12 and we divide that by 4, and that is the result. So we have 2x squared divided by x is 2x, 3x, the x is cancelled, 8x divided by 4, 4 into 8 is 2, and there's nothing else. Then we say 12 divided by 4 is 3. Right. And there we have common factors again. So we will take the common factor and then divide by the common factor. So we will factorize a bit further by taking a common factor of 2x minus 3. So we have x, 2x minus 3 right there, and we divide that by 2x minus 3. Then we have 4, 2x minus 3, we have it here, then we divide by 2x minus 3. So we take the common factor and we divide each term by the common factor. Of course, these will eliminate each other, and we have x. These will eliminate each other, and we have 4. So we have 2x minus 3 and x plus 4. And that's all there is to it. So we have a total of 28 tickets. X were for adults, and the number of tickets for children must be the remainder. So X were for adults. So what do we imagine? If we have 28 tickets, X were for adults, then what do we imagine? If we have 28 tickets and we have 8 of them for adults, how many will be for children? We just take away the 8 from the 28. It is the same thing here. If X were for adults, then what will remain? 28 minus X for children. The amount spent on adult tickets must be equal to the cost of each ticket, which is $30, multiplied by the number of them. So you take the number of them and multiply by the cost of each one. That's not very difficult. So 30 multiplied by X. And what about for the children? The same applies here as in Roman 1b above. The amount spent on tickets for children is equal to the cost of each one, which is $15, and we multiply that by the number of them, which is 28 minus X. So we take the cost of each one, which is $15, and that we multiply by the number of them, which is 28 minus X. So 15 multiplied by 28 minus X. the total spent on tickets must be the sum spent on adults tickets added to the sum spent on children tickets. The total will be the amount spent on adults tickets and add that to the amount spent on children. There we have it. And we are required to simplify that expression. So we take that 15 and we multiply that by 28. When I'm required to do something like that, I can do it mentally. I usually say 15 and treat it as 1.5. So we say 1.5 times 28. 28 is 28. A half of 28 is 14. 28 plus 14 is 42. But do not forget that it is not multiplied by 1.5, it is multiplied by 15. Therefore, it is not 42 but 420. And of course, 15 multiplied by x is 15x, and this will return as it is. I can imagine before the next step we realize that negative 15 plus 30, which is of course 30 minus 15 is 15. So in the end we should have 15x plus 420 or 420 plus 15x, and that is the amount spent overall. To find the number of adult tickets, which is x, as we have it right up here, to find the number of adult tickets, we may equate the expression, which is the one that we have arrived at right here, that expression in x, we may equate that expression in x for the total number of tickets, right, and that we will equate to the known amount of money spent on those tickets. Of course, that is given to us in the statement of the problem. So we equate the expression for the total number of tickets that contains x to the known amount of money spent, and we'll be able to find x there. Of course, we will eliminate this 420 first by subtracting 420 from both sides, in which case from the left hand side 420 will be eliminated, and here we have 660 minus 420, and that will be 240. There we have it, and that is equal to 16. Sometimes I like to exercise my brain, especially when I see a number like 15. X is equal to 240. I'm saying to myself, what number do you take 1.5 times, because 1.5 is related to 15 and the result is 24? Then it is easy to say that it is 16, because half of 16 is 8. 8 plus 16 is 24. So I can do that mentally and say x is equal to 16. Nice. Here we have our problem involving sets. The set A contains the odd number members of the universal set. Odd numbers are not divisible by 2. They are the numbers that end with 1, 3, 5, 7, and 9. So let us write down the set A. But the set A of odd numbers must be of the odd numbers that are in the universal set. So write down those odd numbers. 51, 53, 55, 57, 59. Those are the odd numbers. B contains the prime numbers. They are contained in U. The only even prime number is 2. So since 2 is not in this universal set, all of the elements in the set of prime numbers will be odd. So if all of those prime numbers will also be odd, then the set of odd numbers must contain the set of prime numbers. Or we may say that the set of prime numbers must be contained in the set of odd numbers. Right. the only even prime number is 2 and it is not there. So all of the prime numbers must also be odd. The 50s contains at least 2 numbers that look like prime numbers but are not. They are 51 and 57. 55 also is not a prime number. Let us write down the members of the set B. Of course, 55 does not look like a prime number at all. Right, so let us write down B. B, 53 and 59 alone. We are saying that 51 is not a prime number, 55 does not look like one, and also 57 is not a prime number. So only prime numbers are 53 and 59. So 53, 59. Those are the prime numbers. In completing the Venn diagram, we have to consider that since all prime numbers apart from 2 are odd, that the set of prime numbers must be contained in the set of odd numbers, since they will all be odd. Begin by placing the members of B first. So we have the two sets. B is required to be inside of A, because all prime numbers between 50 and 60 are also odd, so they are required to be in the set of odd numbers. Put in the set of prime numbers first. So the first prime number is 53 and the other one is 59. We do not have any other, so the other odd numbers will be outside of B but inside of A. 51 is inside of A, 55 is inside of A, 57 is inside of A. They are not inside of B though. The even numbers will be in the universal set only. So the even numbers will be 52 right there in the universal set only, 54, 56, 58, and that's all there is to it. As stated before, apart from 2, all other prime numbers are odd. Therefore, considering the universal set, the prime numbers must be taken from among the odd numbers. 51 is not a prime number. If there is a number whose digits have a sum of 3, then that number is a multiple of 3. So that's a rule of thumb. 5 plus 1 is equal to 6. Therefore, 51 is not a prime number because 6 is a multiple of 3. So 6 is a multiple of 3. Therefore, 51 is also a multiple of 3. The same thing applies for 57. When we add 5 plus 7, we get 12. Since 12 is a multiple of 3, so is 57. So 12 is a multiple of 3. Therefore, 57 is also a multiple of 3. 57 is therefore not a prime number. 55 is more obviously not a prime number. The double 5 tells us that it is a multiple of 11. Also, it ends with a 5, indicating that it is divisible by 5. So finally, prime numbers are numbers that are only divisible by themselves and 1. Let us look at the factors of the numbers. So 51 has factors of 1, 3, 7 and 51, which is more than itself and 1. And 57 has factors 1, 3, 19 and 57. 55 has factors 1, 5, 11 and 55. They usually have more than 2 factors. They are therefore not prime numbers. Our first step in constructing the triangle is to draw the line DE, which is equal to 10 centimeters. Of course, we are constructing a triangle and we are doing that to particular specifications. So the first step is draw DE 10 centimeters. With the aid of the ruler, draw a line 10 centimeters long as shown. So there is our ruler, and we will start there and end down the road 10 centimeters, or of course 100 millimeters. Let us label those points at the end of the line DE. CDE is 45 degrees. So this angle, which is CDE, that should be located at the middle letter, therefore it should be located at D. So the 45 degrees angle, the angle is located at the middle letter, which is D. So let us therefore construct that angle at D. The process will not be carried out, only the constructs will be shown. And what does the construct represent? This here, we have this large portion here, is our 90 degrees construct. And of course we have the construct, which is the rest of it over here, which is the construct that we use to bisect the angle. So in forming a 45 degrees angle, we construct a 90 degrees angle first, then we bisect it. Half of 90 is 45, that's all. So in this case, only the construction lines are shown. DC is 8 centimeters. That's what it said. DC is 8 centimeters. So what do we do? Draw DC from D through the 45 degrees arcs. So here marks the 45 degrees. So draw from D through these arcs all the way a distance of 8 centimeters, and there we will locate the point C. Where is that point C? I hope it is somewhere near. Well, we do not have it yet, but maybe by the completion of the triangle we will have it included. There it is. So complete the triangle, and there we will have our point C. In order to construct CF perpendicular to DE and meet DE at F, we will proceed as if we are constructing a kite whose diagonals are perpendicular to each other. CF will be a part of the diagonal. So we are trying to complete a kite by getting this line to be down here and this one down here also. So in a kite we have these two adjacent sides equal in length and these two adjacent sides equal in length. And because of that construct, then the diagonal that goes from C all the way to the other side over here will actually turn out to be perpendicular to this one, as we generally have in a kite. So in order to do that construct, what do we do? Place the point of the compass at D. So put the compass point here and open it in such a way that the point of the pencil is at C. So we put the point of the compass here, open to C. What does that achieve? We are trying to get the same length as DC down here. So there's our arc. And we need to get the same length as CE over this side also. So we'll put the compass point at E, then open the compass to C in such a way that the pencil is at C and the point of the compass is at E, and then we make an arc to cross this one. So what will happen is that this line will be equal to where it goes across here, and then this one will be equal to this one there. So let us make that arc right. We will not complete the kite because it's not a necessity. All we need to do is draw the line right here, 90 degrees. But we are saying the idea of getting it done is to consider that the kite will have diagonals that are perpendicular, and if we can create the frame of that kite, then we are sure to get this line that goes from C to F that we have not yet placed here will be perpendicular to this line. The line from C to its intersection of the arcs will be perpendicular to CD. Where it intersects CD is the point F. So we finish by drawing the line CF. Right, so we imagine that for the kite, this diagonal is perpendicular to this one, but we do not need the entire diagonal. We just need to have the line CF, which will end right there. To measure the angle DCE, that's the angle that we need to measure. Place the center of the protractor at C and use DC as the zero line. Although we could put the center of the protractor at C and use CE as the zero line, because we want one of these lines to be on the zero line, and then we measure the angle maybe in that direction. This line will be the zero line. We measure the angle in this direction. So any one will do. But in this particular case, we are saying put the center of the protractor at C and use DC as the zero line, like so. What do? We take note of where this line intersects the scale. So we are taking a look at where the line CE is tipping on the scale right here. And then that, because this point here, this line is our zero line. So the angle goes all the way around here and increases in this direction to right here. And we'll take note here of what the angle turns out to be. Let us see, we have about, for sure, 80, 1, 2, 3, about 84, maybe 85. So DCE is 84 degrees. The angle obtained here is a bit different from the one obtained on paper. Paper provides a more accurate device to work with. Apart from that, even candidates who are all working on paper will get answers that vary a bit. So all students will not necessarily get exactly 81 if the answer is 81. Some might get 80, some will get 82, maybe 83, and so on. So, as a matter of fact, there is no such thing as a perfect construct. So we imagine that it might be a little bit off sometimes. The time that the bus spent at Chagville is equal to the difference between the departure and arrival times. So there we have Chagville, we have the departure time, and then we have the arrival time. So the time that it spent there will be the difference between these two times, and that turns out to be a mere 10 minutes. Not difficult. 7:45, 7:35, 35 from 45 is 10. There's nothing to it. The time that the bus spent at Chagville is 10 minutes. What is the next one? The time that the bus takes to travel from Bellevue to Chagville is equal to the difference in the arrival time at Chagville and the departure time at Bellevue. So the time that it takes to arrive to Chagville is the difference between the time that it takes to depart from this one and the time that it takes to arrive right here. Find that difference. And of course, no problem, we just 7:35 minus 6:40, 55 minutes. If it is that simple. If not, then we'll take a second look at it. We could have done that mentally by saying that from 6:40 to 7 o'clock is 20 minutes. From 7 o'clock to 7:35 is 35 minutes. This gives a total of 20 plus 35 is equal to 55 minutes. Therefore, when we are handling time, if we just use some very simple common sense strategies, then we have no difficulty making the calculation. So from 6:40 to the hour is 20 minutes, and from the hour to 35 minutes is 35 minutes. 20 plus 35 is 55. That's all there is to it. we need to calculate the distance between Bellevue and Chadville. What do we have? We have the speed. It was given to us in the statement of the problem. As a matter of fact, it is right here. 54 kilometers per hour. And we also have the time. So the distance is equal to the speed multiplied by the time, as we have right here. So distance is equal to the speed multiplied by time. So the distance is the speed multiplied by the time. That will be some great distance if we multiply 54 by 55. If we multiply 50 by 50, what do we get? 50 by 50 will give us 2,500. So what we are calculating will be greater than 2,500. And you do not imagine that we would travel over 2,500 kilometers, maybe to get to school, or maybe on a bus when it takes 55 minutes alone. Well, that is horrible. The time is in minutes and the speed is in kilometers per hour. We therefore need to convert the minutes to hours. This will be done by dividing by 60. So we will divide the minutes by 60 to get hours, and then the distance traveled will be more realistic. So 54 multiplied by 55 over 60, and then we can do a little fraction reduction where we say 6 into this is 9, 6 into this is 10, then we multiply this and then divide by 10, which is reducing by one place of decimal, and no doubt we will get 49.5 kilometers. Always take advantage of the fact that if you are multiplying by a number like 55, then that calculation can be done quite easily. You take the 5 out and use it to multiply. So if you take the 5 out and multiply, remember what we had from here is that we are dividing this by 6 and we get 9. So take the 5 and multiply by the 9, we get 45. Right. And when we are multiplying by 11, we add the two end numbers, the 4 plus the 5, and then put the sum in the middle. So if we are multiplying 45 by 11, we say 4 plus 5 is 9, and put the 9 in the middle, 495. But we are dividing by 10, so it's 49.5. There we have another take, and the one that we said we will take a second look at. Now we are taking a third look at it. Apart from the argument that we used on the previous slide, which is we are measuring against the hour. So 40 to the hour is 20, and then 35 from the hour is 35. 20 plus 35 is 55. So apart from the argument that we use, which is the one that we have just discussed on the previous slide, in carrying out the subtraction, we could have considered that 40 is greater than 35 and therefore cannot be subtracted from it. We therefore take 1 from the hours and use it in the form of 60 minutes. So we take 1 from the hour, leave 6, and then use it in the form of 60 minutes. Now this 60 will be added to the 35, and that will give 95. So now we have a total of 60 plus 35, which is equal to 95 minutes to take 40 minutes from. So 95 minus 40 is equal to 55 minutes. Like that. Kind of like what we normally do from primary school, or primary school mathematics, if it was taught to us properly, will go a long way throughout our entire career as mathematicians, even up to the PhD level. Needless to say that on the hour side, 6 minus 6 as we have it here is 0. As we know, 6 minus 6 is 0, so we don't really need to mention that much, although we have it right here also. Can you remember how early in our instruction that we learned to do these things? No later than at the primary level. I'm just emphasizing how important it is to know mathematics, or to be taught mathematics properly from the primary level. Here is our cuboid, and let's see what is required. The diagram represents a cuboid. It is a three-dimensional figure. A cuboid has all faces being rectangles. Therefore, the area of any face may be found by multiplying its two dimensions. That means if we need to find the area of that face, we need to multiply the h by the 4. So, area is equal to length times width. Being rectangular in shape, we have 4 times h. 4h. That's our expression in h. Also, the volume is equal to, because it is a prism, the cross-sectional area times the length. The cross-sectional area times the length. So, in finding the volume, we may look at the figure in any way we want. We may look at it as a prism and multiply the cross-sectional area by the length, or we may take into account the fact that the volume is the product of length, width, and height. So, being a prism, or a rectangular prism as a matter of fact, or a cuboid, we may take advantage of the fact that we can say area times length, which is cross-sectional area times length, or we may say the volume is equal to length times width times height. However, the area contains two of those dimensions already. So the area would have contained the width and the height already. And this is the area. So all we need to do is multiply by the other one. So for the volume, length times width times height, but the area contains the length and the width already. So the area contains the width and the height already. Therefore, we just multiply by the 13. So we have 4h times 13. 13 times 4 is 52. We have 52h right there. We have the formula for the volume of the cuboid right here. In finding the height, we need to make use of the equality. What equality? We are supplied with the volume in the statement of the problem. And we have the formula for the volume right here. So we equate the formula for the volume with the value of the volume that is given to us in the statement of the problem, and we have 52h is equal to 286, which is the volume supplied in the statement of the problem. In finding the height, all we need to do is eliminate the 52 from this side by dividing, and do the same thing on the other side. So we will have h is equal to 286 divided by 52, and that will turn out to be 5.5 centimeters. Very nice. We have a problem involving geometry. What do? We were informed that ML is equal to MP. Sometimes we realize that in the examination they give us a lot of information in the diagram, and for the most part we should be able to solve the problem based on the information that we have given in the diagram. However, it pays a lot to read the statement of the problem, because especially in this particular case, it would not be so easy to determine the value of the angle that is solicited in this part of the problem if we do not take advantage of the fact that ML and MP are equal. So that makes the triangle isosceles, this side being equal to this one. Therefore, these two angles are equal. There we have the triangle that we're talking about, isosceles, with these two sides equal. And then what do? MLP is one of the equal angles, and all of the angles in a triangle add to give 180. So we subtract the 36 and then divide into 2 for the two equal angles, and the result turns out to be 72 degrees. But sometimes we might forget that 72 degrees, and when we are attempting to find another angle, the 72 degrees will play a very important role. But because we did not make note of it in the diagram or anywhere else, and sometimes we do not remember, we are going through the entire thing and cannot find a way to determine the other angle. So let us put them right there. So those two angles are 72 degrees each. What about the other angle? The other angle that we need to find, KJ and LM are parallel. Therefore, usually in mathematics, as soon as you see a diagram with parallel lines, you want to think about alternate angles. So JK and LM are parallel. Therefore, JML and LJK are alternate angles. So these two angles are alternate angles, or what we call Z angles, because these two lines are parallel. So 22 degrees, they are equal. F angles. So JKL and MLP are equal angles since they are formed by parallel lines that intersect a single line, which we call F angles. So these two angles, this one and this one, are equal because they are formed by two parallel sides that intersect a single line. So 72 degrees. And I am sure that the final one cannot be so difficult. KLJ is the angle that completes the angle on a straight line that is shared by those other two angles. KLJ is therefore that which remains of the 180 degrees. Now this angle that we have here is 22. See right there. And then this one is 72. And this angle on a straight line, therefore this angle is what remains of the 180 degrees when we subtract the 22 and the 72. And that turns out to be 86 degrees. More geometry, but coordinate geometry in this particular case, and specifically transformation. State the coordinates of P and Q. What's the coordinates of P and Q? Notice that for P, 2 units in the X direction and 1 unit in the Y. 2, 1. What about Q? 4 units in the X direction, 3 in the Y. 4, 3. The transformation is a reflection because the triangles are different in orientation, and the difference in orientation was discussed in practice paper 9. Therefore, here we will take the opportunity to discuss another feature of reflection. Now, what do we mean by different in orientation? Look at this. If we are saying PQR, PQR, we are going in that direction. Anti-clockwise going PQR. But if we say PQR down here, we are going PQR, we are going in a clockwise direction. Therefore, the transformation is a reflection. Reflection is the only transformation that we study in this syllabus that gives this effect, where if we say PQR, we are going anti-clockwise, and if we say PQR, we are going clockwise. That kind of situation tells us that we are talking about a reflection. There's no doubt that it is a reflection. And some students will realize that we have these laterally inverted. One is the lateral inversion of another. by looking, so the candidate should be able to tell that it is a reflection. And maybe that is the reason why the examiners did not ask us to explain why, just to say what transformation do we have there. In a reflection, the line joining points to their images are parallel. Right. In a reflection, the line joining points to their images are parallel. But the same is true for a translation. The same is true for a translation. In a translation, the lines are equal in length, but in a reflection, they are not. So, in a reflection of a polygon, at least a polygon, the line joining points to their images, as in every single case, will be parallel. But for the reflection, if it is a polygon, they will not be of the same length. The mirror line must be perpendicular, because when we are describing a reflection, we have to state the mirror line. That's a must. The mirror line must be perpendicular to those lines and also bisect them. So there is your mirror line bisecting those lines, and it is perpendicular to them. So on this side of the mirror line we have 1, 2, 3. Here we have 1, 2, 3. Here we have 1, and there we have 1. So the mirror line should bisect the other lines, that are the lines that join their points to their images. So the transformation is a reflection in the x-axis, and the equation of the x-axis is y is equal to 0. On the grid, the translation may be done graphically. However, we do not have the space on this grid. Let us therefore use the method of adding the vector of translation to the positioned vector of the points. So that point, the vector of translation was given to us as 3, negative 6. So to 2, 1, we add 3, negative 6, and the result is 5, negative 5. But that is not the answer, because we need the coordinates. So we write the coordinates 5, negative 5. So in the examination, it is not a complete answer to just do this, because what we have here is not a pair of coordinates but a position vector. Therefore, we need to write down the coordinates of the points. And no doubt, we will do the same right there. Adding the vector of translation to the position vector of the point Q, and this is the result. And of course, again, this is not a pair of coordinates but a position vector, so I write that as a pair of coordinates. Here we have a table of values of x and y that pertains to this equation, and of course we have 2 values of y that are missing, and we need to complete that table. Complete the table by substituting the values of x into the equation. So we have x squared minus 2x minus 3, and we do not have the y value when x is equal to negative 1. So negative 1 squared minus 2 times negative 1 minus 3. Square negative 1, we get a positive 1. Negative multiplied by negative is positive, so we'll have 1 plus 2 is equal to 3. Then we minus 3, and that is equal to 0. And 0 goes right there. Do the same here, substituting 2. What do we know? What do we expect? Well, we expect the value to be negative 3, because we say 5, 5, 0, 0. And then negative 4 is in the middle, so we imagine that it could be negative 3 right there. Although on some occasions the CSEC examiners kinda cause one of the digits to be skewed, one of the values to be skewed, that when you calculate it, it is somewhat different from what you would expect in the table, which of course is a correct value. But they try to make sure that the students or the candidates will not be able to just look at it and tell what the value is. But I realize that in recent years it is more predictable than in former years. So we put a 2 here into this equation. 2 squared minus 2 times 2 minus 3. So square 2, we get 4. Then we have a negative 4 here. So that's a 0. And then minus 3 is equal to negative 3. And of course we put the negative 3 right there. And the table is now complete. Let us draw the graph of the function. The scale will not be the same as in the statement of the problem. Consult the accompanying booklet and the presentation video for the correct scale. So we are not using the exact scale given to us in the examination. As a matter of fact, you will discover that these might not be exact 2 centimeters, or this as a single centimeter. So the graph is a very good representation of what we should have, but it might not be to the exact scale because this grid was designed on the computer and not from a graph paper. So let us plot that point. -2, 5. So -2, 5. -2 in the x direction, 5 in the y direction. -1, 0. -1 in the x direction, no movement at all in the y direction. The point will be right here. So we do not move again. 0, no y movement right there. Then what do we have? No x movement. -3 for the y. So 0, -3. So no x movement, but -3 for the y. So we have right there. What do we have next? 1, -4. 1 in the x direction and -4 in the y direction. 1, -4. The point will be right here. And then we have 2, -3. So go to 2 for the x and -3 for the y, and the point will be right there. What else? 3 for the x and no movement in the y direction. The point will be right here. Generally in the classroom situation, students get confused when they need to make use of a value of 0 as one of the x or y ordinates. Maybe they always want to go back to the origin when they see a 0, but they need to understand that we have 0 for the y, but the x movement is -1. Therefore, it cannot be at the origin, and also in these particular cases. Of course, I've seen graphs that pass through the origin, and no doubt the x and y ordinates will be equal to 0, both of them. But we can take a second look at the way that we plot the points for this graph and other graphs in arriving at the location, the correct location of a point when one of the ordinates is equal to 0. So there we have 4, 5. So 4 for the x and 5 for the y. What else do we do? Finish up by drawing the smooth curve through all of those points. What do we do next? We need to determine the value of y when x is equal to 3.5. So we locate 3.5 on the x-axis. Then draw a vertical line to meet the curve. But what are we really doing? we are actually finding where on the curve x is equal to 3.5. So actually x is equal to 3.5 right here on the x-axis, but the corresponding point on the curve, for the corresponding point on the curve, we need to go right there. There is where we will locate it. Right there. What do we do next? Draw a horizontal line to meet the y-axis and take note of the value of y. So there's our horizontal line. It goes straight across, and we are trying to determine the corresponding y value, and y is equal to 2.2 units. We have other things that we need to be able to determine by the use of that curve. The axis of symmetry is a line that divides the curve into halves that are mirror images of each other. Or we may say that it is the vertical line that passes through the extreme point, which is the maximum or minimum. In this particular case, it is a minimum. So it passes through the minimum point on the curve. So there we have our axis of symmetry going straight through the minimum point on the curve, and of course dividing the curve into halves that are mirror images of each other. No problem. X is equal to 1, so it passes through the value of x and the axis, the x-axis, where x is equal to 1. So x is equal to 1 is the equation of that axis of symmetry. Now we need to determine the minimum value of the expression or the function. The minimum value is the lowest point on the curve. It coincides with the axis of symmetry. The minimum is given relative to the y-axis. So there it is. The minimum point is right here, given relative to the y-axis. So the minimum value is y is equal to 4. Anything else? I'm sure else we wouldn't have this light space right here. There we have an equation that we need to be able to solve without using the quadratic formula and without factorization. Just to look at the graph and tell. The equation is saying that the function is equal to 0 or y is equal to 0. We have the entire expression is equal to 0. But in the equation, y is equal to x squared minus 2x minus 3. Therefore, y is equal to 0, and also x squared minus 2x minus 3 is equal to 0, because y is equal to x squared minus 2x minus 3. So in the equation that we have right here, we have somehow encrypted the statement that y is equal to 0. Y is equal to 0 on the x-axis. As a matter of fact, y is equal to 0 is the equation of the x-axis. Therefore, we need the values of x where the curve crosses the x-axis. Y is equal to 0 on the x-axis. Y is equal to 0 is the equation of the x-axis. So we need the points where the curve crosses the x-axis. As a matter of fact, the plural word values that we have in the statement of the problem indicates that there should be more than one of them. So where they are, here and there, so these are the two values where y is equal to 0, where the expression is equal to 0, where the expression crosses the x-axis, and we have -1 and a +3. This is a favorite, and I would say that this problem, I enjoy working with this problem because we do not have one like this coming on the paper or similar to it quite often, and it is basically some deviation from what we normally have. I always welcome something like this on the examination. In completing the table, because we need to complete the table that we have right here, let us first complete the mid-interval values of the classes. We may find the average of the class limits. So the mid-interval, or the midpoints, or the mid-interval values will be halfway between 1 and 10. That may be calculated by adding 1 plus 10 is 11. Divide 11 by 2, we get 5.5. And if we add these, we get 31. Divide 31 by 2, we get 15.5. We can just take a look at this and realize that it is going up by 10 each time. But let us do another one first. So let us do another one first. We have 21 plus 30, and we divide that by 2, and we get 25.5. There. And of course, we are increasing by 10 each time. So the values are in a sequence increasing by 10 each time. So continue the sequence going up by 10 each time. We get 35.5, and going up by another 10, we get 45.5. But what do we know about the other? The height of each bar is the frequency of the respective bar. So the height of a bar is the frequency of the class. So no doubt we have this bar here, which is the second one, going all the way up to 25. And that is why we have the 25 right there. And we have the first one at 18. But let's see what this one is. The next one that we have is right there. So we have 20 here, and this is about 25. So we may consider that that one is about 23. Now on the one that is given on the examination paper, we can determine the values exactly, but we do not have the luxury right here. So for the most part, we can go at an estimation unless we have one is 10, the other one is 15 or 20, 25, so on. Like this one is exactly on 20, so we may just write that down, 20. And then what do we know? 10, 15. So this one is a shade below 15, so we can safely say it's about 14. Right. The mode, we need to determine the modal class. The mode is the item that occurs the most, and its class is associated with the highest frequency. So the mode is the item that occurs the most, and its class is associated with the highest frequency. So the highest frequency is 25. So the modal class is the class that goes from 11 centimeters to 20 centimeters. Right. The number of seedlings in the sample is the sum of all the number of items in the categories, which is equal to the total of the frequencies. So the number of seedlings that we have, the total number of seedlings, will be the total of all of these numbers. And that turns out to be, when we add them, 100. And I was looking a bit at it and say that its addition, the sum, looked to be a little bit different from 100. But when I say 23 plus 14, that gives us 37. And then we have another 18 here with the 37, and that should give us 55. And then we have another 20, so that's 75, and 25 is 100. That's not difficult. In finding the mean, because we need to find the mean now, we need to extend the table, and we have the extended table here. We need additional cells for the sum of f. So the summation of the frequency needs to be there, and we need additional cells for the summation of f and the summation of fx. Hence an additional column for fx, which is what? This product of f and x. And what do we consider to be x? The mid-interval point. Because what we are attempting to do is find we're adding all of the values, or all of the possible values, and we have 18 of them right here. 18 of what? 18 of 5.5. So 18 values, each one is 5.5, so we multiply the 18 by 5.5. But actually, if the statement of the problem is giving us an indication, then we should take it. It says find an estimate of the mean, because we're not actually finding the mean, because we do not know in the range from 1 to 10 how many are closer to 10 than to 1 or in the middle. So it's an estimate. Since we cannot, or it is not going to be wise to use, and we should not either, because we do not have all of the values inside here. We just know that from 1 to 10 we have 18 values. So it's merely an estimate to say that we are using the mid-interval values, but multiply that by 18. So let us find the product of f and x. That's that. Any more? Yes. 15.5 times 25, and then 25.5 times 23, and then 35.5 times 20. And then the other one, we do not have a statement down here, is 45.5 times 14. Now, the summation of the frequencies was determined from the previous slide. Additionally, we need to find the summation of the product of f and x. So we need to find the summation of fx, and we need to find the summation of f. We have done that from the previous slide. It is 100. So 100 goes there, and the summation of this goes there, which is about 2,420. Right. And how do we calculate the mean? The mean is given by what? X bar is equal to the summation of fx over the summation of f. So 2,420 over 100, and that gives 24.2 centimeters. What is all of this space for? Another problem. Now we need to determine the probability that a seedling has a height greater than 30 centimeters. So the probability that a seedling has a height greater than 30 centimeters will be found by dividing the number of seedlings concerned by the total number of seedlings. Those seedlings are in the class 31 to 40 and 41 to 50. Those that have a height greater than 30. So we have 21 to 30. Those in this category will have heights 21 to 30. But here we have 31 to 40, which is greater than 30, and here we have greater than 30 also. So the number of seedlings in these two classes divided by the total number of seedlings. So we have there 20 plus 14, and that we divide by 100. And we get 0.34, because we get 34 divided by 100, and that is 0.34.